Welcome back to All This Math. This is Professor Parker. And first off, shout out to Shirley Chisholm, the ancestor, Shirley Chisholm. She actually ran for president back in 1972, president of the United States. She was a sister. She was already a politician. She lived in Brooklyn. Her family was, I believe, Bayesian. I think she was from the Barbados, like Rihanna, right? So that's a connection. But yeah, go do some research on Shirley Chisholm. Shirley Chisholm. She was the first Black person to run for president, I believe, back in 1972. Also the first woman, I believe, to run for president of the United States back in 72. All right. So for today's lesson, we're going to do some subtraction without borrowing. Now, why is it significant that we're not borrowing? Is because typically with problems like these three examples I got up here, you would need to borrow, right? That's the traditional method. You borrow from the next place value. You know, if you're in the ones place, you borrow from the tens place. If you're in the tens place, you borrow from the hundreds place, so on and so forth. But it's other ways to do these types of problems. You can subtract without borrowing, right? And this just goes to show you that there are a lot of different methods that we can learn and we can utilize and implement in mathematics. And we should become comfortable with knowing how to do different methods, right? What I like to call this method I'm gonna use, I like to call it the same difference method, the same difference method. When I was younger, I used to hear people say like the phrase same difference, and it would confuse me so much. I didn't really know what they meant. But nowadays I understand what they meant. The same difference is because when we're subtracting, the actual numbers that we're using to subtract really aren't that significant. I mean, they are to a degree, but then at the same time, they're not. Because what we really want to find out is the difference between the numbers. And we don't have to use these same numbers to find the difference between these numbers. Because while these two numbers have a certain difference in numbers between them, or a certain amount of numbers between them, right, which we call the difference, right? In math language, when you see the word difference, you notice some subtraction is going on, right? There are other pairs of numbers that have the same difference between them. So with that in mind, what we could do is say this. We could say, look, if I change the numbers, right, in a way that allows me to keep the same difference between the pair of numbers, right, where I don't have to borrow, I'm still going to get the right answer. I'm still going to get the right answer. So here we got, let's look at the first example. We got 225 minus 169. All right, so we want to know the difference between the number 225 and the number 169. How many numbers are in between? Now, it's a lot of ways to do this problem. Let me first say that. It's a lot of ways to do this problem. It's no one way to do that problem. It's a bunch of ways, right? One way to do it would be to borrow. We could borrow because we say, look, when the top number in what we call the minuend, that's a little bit of math vocabulary for you. The number that in a subtraction sentence, right? The first number is called the minuend. That's a vocabulary term, the minuend. M-I-N-U-E-N-D, minuend. The number that's being subtracted, we call that the subtrahend. All right, it's called the subtrahend. So 225 is the minuend. 169 is the subtrahend. All right, now, when the problem is set up like this, set up vertically, the numbers stacked on top of each other, when the minuend has digits that are smaller than the digits in the subtrahend, that poses a problem for us. That poses an issue. It's something we can handle, but it's a problem we got to deal with, right? This 5 is less than 9. 2 is less than 6. So using this typical method, this traditional method, we're not able to do 5 minus 9. Now, be very careful if you're a parent talking to your children about this, or even if you're an elementary school teacher talking to children about this. Do not have them thinking that you cannot do 5 minus 9 under any circumstances, because in another scenario, we can do 5 minus 9. It'll take us into the negative numbers. But using this method, 5 minus 9 is not allowable because we only want to end up with positive numbers, right? So if we were going to borrow, I would borrow 10 from this 2, which is really a 20, and I would make that 5 a 15. So now the number in the minuend is bigger than the number in the subtrahend. So then the subtraction is easy because using that typical method, we always want to end up with positives. But let's say we don't want to borrow. What I like to do is this. Because again, my goal is for every digit in the subtrahend to be less than every digit in the minuend, right? Now that's not the case. So what I like to do is I like to change all the digits in the subtrahend to zeros. At least, maybe not, I don't need to change this 1 into a 0, but this 9 and this 6, I want to change those into zeros. So watch what I do, right? This how I do that. In order to change this 9 into a 0, I could change 169 into 170, or I could change 169 into 180, 160, as long as the number ends in a 0, right? I'm going to change it to 170. So watch this. That's going to become 170. And now, because I changed this to 170, I want to keep the same difference between the two numbers. So look what I did. If I increase this number by 1, I got to be consistent. I'll also increase the top number by 1. So the 225 is going to go up by 1 also. So I do 225 plus 1, which gives me 226. Right? So now I got 226 minus 170. So the 6 and the 0 are cool. I could subtract those, but now I got a problem with the 2 and the 7. I still got a problem with the 2 and the 7. Right? So because 2 is less than 7. So what I'm going to try to do is I'm going to try to change this 7 into a 0. Right? That's one way to do it. You don't have to do it that way, but I like to just change as many digits in the subtrahend to zeros as I need to, so that all of my digits in the minuend are bigger than the digits in the subtrahend. All right. So now this is what I'm going to do. I'm going to change 170 into 200. I'm just going to straight change that into 200. So that's going to become 200. But look, I changed this to 200 by adding 30 to it. So if I add 30 to that, it becomes 200. And then I got to also add 30 to that. So what's 226 plus 30? 256. 220 plus 30 is 250, right? The 6 doesn't change. So now I can do my subtraction. Now look at all my digits. 6 bigger than 0. 5 bigger than 0. 2 is equal to 2. It's not bigger than 2, right? They're equal. So the digits can be equal, because when you subtract, you're going to end up with a 0. So now we do our subtraction. 6 minus 0 is 6. 5 minus 0 is 5. And 2 minus 2 is nothing. You don't have to write the 0. So the answer is 56, or the difference is 56. And we did that without borrowing. But you got to know how to do some addition, though. You do have to know how to do some addition in order to do this, right? Now, a lot of people might be watching this video saying, why don't we just borrow? Why bother? Well, because it's good to know different methods. It's always good to know different methods. Plus, understanding this helps you to practice with your numerical fluency. And you want to be fluent with numbers. And you want to be fluent with numbers so that you can see the relationships between numbers in different random various situations, right? Now, of course, we could just borrow. We could have just borrowed from the 2, made that into a 15, then 15 minus 9, then that would have been a 1. Then we would have borrowed from this 2, then that would have became an 11. We did 11 minus 6, and that would have been 5, and then that would have been 1, and 1 minus 1 is 0. We'd have still got 56, but that's one method of doing it. Don't be scared to learn new ways to do the same thing, right? Don't be scared to learn new methods and new routes to get to the same result. Don't be scared of that. Embrace that, right? It's good to know different methods because, as I said, by learning different methods, you start to develop more fluency with numbers and you start to understand the relationships between numbers better. And it also trains your brain and gives you more practice. All right, so let's do this next problem. Let's do 342 minus 199. So, all right, so watch this. In our minuend, 2 is less than 9. That's an issue. In our minuend, 4 is less than 9. That's an issue. All right, so watch what I do. This is 199. I can straight change this to 200, and then I'm going to have 2 zeros. 2 zeros. I'm going to straight change that to 200. So this is easier, right? So that's going to be 200. But then what do I have to do to the 342? Because, again, I got to be consistent. If I bump 199 up by 1, I got to also bump 342 up by 1. So 342 plus 1 is 343. And then I do my subtraction. Because look at my minuend digits. I got a 3 and I got a 0. I got a 4 and I got a 0. I got a 3 and I got a 2. So 3 minus 0 is 3. 4 minus 0 is 4. 3 minus 2 is 1. That's my answer, 143. And I ain't had to borrow nothing. So, and also another thing is this, like when you know a lot of different methods for doing math, then you can sit back and choose what you want to do. You have options. And it's good to have options sometimes. I would actually say it's probably good to always have options. Now, you need to be disciplined sometimes and not always exercise your options, right? But in many situations, it's good to have options, all right? Because you don't want to be limited to just one method. Because sometimes when you only have one method of solving a problem, that method may not always be the most efficient or effective method for solving that problem. But if you're stuck and locked into that one method, you have no choice but to use it when you probably shouldn't be using that method. So keep that in mind too. So you want to have different methods. All right. Last example, 315 minus 168, right? Look at our menu. We got a 5. 5 is less than 8. We got a 1. 1 is less than 6. 3 is greater than 1. That's cool. But this 5 and this 1 is a problem. So what I'm going to do is, first, I'm going to change this. And I do a step by step. I probably could do it in one step, but I do it step by step, right? I'm going to change 168 into 170. So I'm trying to change this 8 into a 0. So that's going to become 170. So if I bump this up by 2, I got to bump the 315 up by 2. And if I bump 315 up by 2, now the 315 turns into a 317. So now I got 317, right? So 317 minus 170. This 7 and this 0 is cool. But look at the 1 and the 7. 1 is less than 7. That's an issue. 1 is less than 7. That's the issue. So what should I do? I could, again, let me see, what could I do? I could bump this 7 up and turn it into a 0. How would I do that though? What I would do is I would add 30, just like I did up here with this 170. I would add 30 and turn this into a 200 because we're looking, whenever we do subtraction, we're looking for the difference between the numbers. So that's why we can do what we're doing here, right? So as long as we keep our difference between the numbers the same, right? So that means if just like here, I added 2, I made this number bigger by 2. So I make that number bigger by 2. So that means the difference between the numbers is the same. It's all about the difference between the numbers. That's what we care about. So I'm going to bump this up and make this into a 200, just like I did up here. So then I got to bump this up and make this bigger by 30, right? So 317 plus 30, I'm not worried about the 300. I'm worried about doing 17 plus 30, 17 plus 30. And again, to use this method, we got to know our addition facts, right? 30 plus 17 or 17 plus 30, little commutative property. The order doesn't matter when you add, numbers together. 30 plus 17 is the same thing as 17 plus 30. To me, 30 plus 17 is easier to do. It might not be to you, and that's okay too. So 30 plus 17 is going to be 30 plus 10 plus 7. 30 plus 17 is the same as 30 plus 10 plus 7. 30 plus 10 is 40. 40 plus 7 is 47. So this 317 is going to turn into 347. All right, 347. Now look at my menu in. Look at my digits. 7 is bigger than 0. 4 is bigger than 0. 3 is bigger than 2. Now I can subtract. Now let's subtract. What's 7 take away 0? 7. What's 4 take away 0? 4. What's 3 take away 2? 1. 147 is our answer. All right, 147 is our answer. Now, again, don't get caught up. Don't get discouraged if this don't make full sense, that you just need more practice. It's not difficult. Actually, this is as difficult, if not less difficult, than borrowing. Because borrowing conceptually gets a lot of people caught up and confuses a lot of people. A lot of people are so loyal to borrowing just because that's how we learned it 30 years ago. But just because that's what we learned 30 years ago doesn't mean that we can't use other methods, right? This helps us to understand the concept of subtraction, and what's really taking place is that we are really trying to find the difference between the two numbers, or the difference between the minuend and the subtrahend. That's what we're trying to find out, all right? And we can change these numbers. We can manipulate numbers, right? We have power, right? When we was in elementary school as adults, I don't know about y'all, but a lot of times I felt like I ain't have no power. I had to kind of just follow the rules, do what the rules say, and only work a problem a certain way, not knowing that I could manipulate problems and change the numbers around and still get to the same answer. I didn't know that. Maybe some of my classmates knew that, but I didn't really know that, right? I was kind of locked in to one method. And one method is cool sometimes, but like I say, I think we should have options. I think our children should have options. I think teachers should have options in terms of how we teach it. So that way we'll have a more diverse understanding of mathematics and a more broader understanding of mathematics generally. You know what I mean? All right. So a couple of examples of subtraction without borrowing when we normally would. I call this let me write this down. I call it the same difference method. The same difference method. I don't know if anybody else call it that, but I call it that, Kujichagulia, self-determination. And Nguzo Saba from Kwanzaa, right? We determine things. We call things what we want to call it, right? It makes sense, all right? So anyway, these are some examples of using the same difference method, doing subtraction without borrowing when we normally could borrow. And I hope you enjoy it. Hope you learned something new. But I also want you to go get some practice, right? Practice this, yourself as a parent, practice this as a teacher. And if you're a child watching this, practice this. And also as a parent, practice this with your children. All right. So they can get a better understanding. All right. I'll see you on the next video. Peace.